Hi everybody, welcome back. In this video we're going to be looking at how to find inverse normal probabilities. And in our last class we were looking at how to find inverse standard normal probabilities. And in this video we're going to be looking at what do you do when it's not standard normal, but it's just inverse normal. Okay, so I thought we'd start by reviewing how to do the inverse standard normal probabilities, because just like with the first video from this section, this is going to be one step in a bigger problem. So finding the value of z with 18% of the area to the left. So 18% of the area is this much here to the left. So that shaded area is 0.18. And to find that, we have to use the Excel function norm s inv. And you always tell it the amount that is below, so or to the left. Okay, and here we've got 18% to the left, so this gives us a negative 0.9154. So negative 0.9154. So if we were looking at that where we knew and I had to draw this separately because when we started sketching over here we didn't know where that was going to fall. So there's 0, 1, 2, 3, and there's negative 1, negative 2, negative 3. This is going to be almost at negative 1. Not exactly at negative 1 though, so we'll try to sketch that again. There we go. So that's our negative 0.9154. And this area over here is 0.18. So that's the first one. The value of z with 29% of the area to the right is going to be we've got 29% of the area to the right. When we do norm s inv, if we did 0.29, that would not be the right sketch. That would be the sketch. Don't write this part down. Where we'd have 29% to the left. That's not what we want. So I'm just going to go ahead and erase this, because this is not what we want. So if 29% is above, we have to tell it how much is below. So it's 1 minus 0.29, which is 0.71. Because that's what's left out of 100%. So 1 minus 0.29 is 0.71. So norm s inv 0.71. And we get 0.5534. And keep in mind on all of these, the value we put in is a probability. And then the value we get out is a value of z. Okay, so we put in a probability and we get out a z. So 0.71 is our probability and z is 0.5534. And in this last problem here, we've got 84% of the area between two values of z. Try that again. That's a little better. We've got 84% of the value between of the area between these two values of z. One's going to be negative, one's going to be positive. So if we've got 0.84 in the middle, it means we've got 0.16 on the outside, because it's 1 minus 0.84. And then if we divide that evenly between the two tails, it means we've got 0.08 over here and 0.08 over here. So the easiest thing to do is to find this lower one. Norm SINV 0.08. That gives us negative 1.4051. So negative 1.4051, and then up here it's 1.4051. And those are our two values. So now let's look at what do we do when we want to find an inverse normal probability, but that's not a standard normal. And first of all, let's look at what a problem like that would look like. So in the previous video, we looked at this example where we saw the cost of a new pair of jeans following a normal distribution with a mean of $74 and a standard deviation of $2.50. An inverse normal probability would be if they're saying what would be the cost of the lowest 99%. So what would be the value, the cost, where 99% of all new pairs of jeans would be lower than that. And so what I did was this is the same thing we drew a minute ago. I just put it down here. And we're going to look now at where that 99% would be. So the 99% is going to be somewhere up in here. So somewhere up in here, there's going to be a dollar amount on the x-axis here, with 99% below it. So what we're going to do is we're first going to find the value of z using our norm.s.inv. And then we're going to convert it back to x using this formula, z equals x minus mu over sigma. Okay, so let's start by, again, finding our value of z. So we need the value of z with 99% to the left. So we need this value of z, so that's going to be norm.s.inv .99. And that gives us 2.3264. So that tells us that on the z-scale, this is where we are, 2.3264. And now we have to convert that value of z to x. And if you solve this, you don't have to solve it every time. We can just solve it once. So if we multiply both sides here by sigma, we'll get z times sigma. And then we add mu on both sides. That gives us x. So we can just use x equals z times sigma plus mu. All I did was I took this equation and solved it for x. Multiplying both sides by sigma, and that cancels this out. And then adding mu on both sides. Okay. So we've got here 2.3264. So we're going to say x equals z, which we found to be 2.3264, times sigma plus mu, and mu in this problem is 74. So this mu and sigma is going to change from problem to problem. We got mu from here and sigma from here, and the 99% came from here. So now all we have to do equals, and the easiest thing to do is just to click on that cell where we've got the z value stored, times sigma plus mu and our answer is $79.82. So according to these numbers, which I made up the 74 and the 250. But according to these numbers, the lowest 99% of new pairs of jeans would cost less than $79.82. So the only way I could make that different, make the process different, would be if I changed it from a less than, and here it's less than because it says the lowest. I could make that a greater than, or I could make that a between. So let's see what happens if we make it greater than. So here we want what temperatures make up the top 7% of all days. We're first going to find the value of z that makes up the top 7%. And so we're going to start with norm.s.inv. And if we typed in 0.07, that would give us 0.07 to the left, but we don't want that. We want 0.07 to the right, which means we have to look at 0.93 to the left. So we first find that value. And we get 1.4758. And so now we got to take that and plug that into this formula here, x equals z times sigma plus mu. So we got our Z is 1.4758 times sigma, which in this problem is 4, plus mu is 85. So we're going to take this value we found, multiply it by sigma, and then add mu, which is 85, and we get 90.9032 degrees Fahrenheit. Okay, so the top 7% of all days would correspond to a temperature of 90.9 degrees or above. One more. And that's we've got, this is a between one. Between case where they're saying, what tax refund do the middle 90% of people get? So we first have to find the values of Z. So if we've got 90% in the middle, it means we've got 0.05 in each tail. So we're going to start with norm.s.inv of 0.05. And that's going to give us the lower value of Z, so negative 1.6449. And that means this upper one is positive 1.6449. So Z equals negative and the positive. And now we have to take both of those values and convert to Z, or convert to X using the same formula. X equals Z times sigma plus mu. And in this formula, they told us mu was 800 and sigma was 120. So I'm just going to write this as plus or minus, and I hope that's okay. It's really two separate problems. There's X equals negative 1.6449 times sigma, so times 120, plus mu. So that's the negative, and then there's also the positive. Okay, so plus or minus. So let's start with the negative one. So equals that value we just found times sigma, which is 120, plus 800. And the lower value is 602.618. So that's, we write that as dollars, that's 62. So that's the minus one. The plus one is going to be the same thing, except is going to be negative. So I just put a negative in front of this value that we found. Otherwise, it's the same calculation. And we get positive 997.38. Right? And I want to point out that I've been very careful with the notation, and I want you to be as well. We don't ever want to put norm.s.inv equals 1.4578 times whatever, because that's not what this is equal to. Okay, you got to say, okay, now I'm basically finished with that. Start with the x equals here. Okay, and before we go, just a quick sum up. We've looked at two different kinds of problems. Primarily, we've looked at where you're finding the normal probability and where you're finding the inverse normal probability. To sum up, to find the normal probability, you're going to convert to z. So you've got a probability that starts with p of x something. You're going to convert that to z using x minus mu over sigma, and then you're going to use norm s dist. The way you know it's that kind of problem is that it will tell you that it follows a normal distribution. Here's the mean and here's the standard deviation. And then it'll say find the probability or the percent or the proportion. Okay? So the ones we looked at up there, what proportion of days? What is the probability these people's tax refund will exceed $900? What percent of all people's tax refund will exceed $900? Okay, so that's going to be, those are examples of normal probability. Inverse normal probability, on those you start with norm S, I, and V, and then convert to x. And the way you know that it's that kind of problem is they're giving you the percentage. They're saying what, and I put a blank here because this is context dependent. What tax refund, what temperature, what dollar amount corresponds to the lowest, highest, middle, whatever percent. Okay, that's how you know these are inverse normal problems. So like this one up here, what temperatures make up the top 7% of all days? They gave us the percentage, and then they asked us to find the temperatures that corresponded to that. All right, so that's it for this lesson. And, of course, as always, please let me know if you have any questions. I am always happy to help. See you later.